everyone, good morning. Today we'll be doing the AMC-8 2023 problems and solutions. So we'll be discussing some key strategies and tips to improve your score on the AMC-8. And you can ask some questions and I'll be able to answer them at the end of this session. So let's get started. Problem number 1. What is the value of 8 times 4 plus 2 minus 8 plus 4 times 2? So we can't just simply solve this. We need to follow the order of operations. And by the order of operations, I mean that we need to follow PEMDAS. And PEMDAS, it stands for parentheses, exponents, multiplication, division, addition, and subtraction. So in this case, is there any parentheses in here? Yes, there's actually 2 parentheses. And we need to solve from left to right. So if there's 2 parentheses, then what's inside the parentheses? Well, there's multiplication and addition inside the parentheses. So, would addition come first or multiplication? Well, according to PEMDAS, multiplication would come first. So we would have to solve from left to right. And in this case, we would have to do 8 times 4, which is 32, minus plus 2 here, and minus here, and we would have to do 8 plus 4 times 2. So once again, we would have to follow the order of operations, and here we would be getting 8 plus 4 times 2, which is 8. So now we can solve whatever's in the parentheses once again, and we'll be getting 34 minus 16. And 34 minus 16 is going to be equal to 18. And that's how we got our final answer D. Problem number 2. A square piece of paper is folded twice into 4 equal quarters as shown below. Then cut along the dashed line. When unfolded, the paper will match which of the following figures? So we can just try to visualize this, or I have a piece of paper to show this. So here, I'm going to fold this paper in half. And then fold this paper again in half to make 4 equal quarters. So I fold this paper in half. And now this part right here, this part is the flappy side, meaning that this corner is here. And they say that they cut right there. And so they cut somewhere like this. So I have a scissor and I'm going to cut it somewhere here. So then this shape should be looking something like this. But when they unfold it, how is it going to look like? Well, first let's try to visualize this before I open this piece of paper. So would it be A? Well, it would be A if they cut it somewhere like here. But remember how they cut it in the corner, which cannot open? It's like the center part of the square. That means that they cut it somewhere around this area. So A cannot be the answer. B cannot be the answer either because it would have to be equal into 4 parts, not just 2 of these. It would have to be into 4. So B cannot be the answer. C might be the answer, question mark. And D cannot be the answer again because once again it has to be cut into 4 equal parts, meaning that it might work if it's like this. So, can E be the answer? Yes, it can, maybe, because it's the center part. So now, let's prove which one is correct, either E or C. Well, C, there's a right, so it should be looking something like this here. And this one should be looking something like this. Look at C right here. They cut it somewhere like this, maybe, because we can see that there's a right angle here and a right angle here as well, in the center too. But here, it's just cut into half of that. It's cut like that. And so C cannot be the answer because this is a right angle and they did not cut it into a right angle here. So in this picture, we can try to unfold it to just prove why our answer is E. So if we unfold it, then it should be looking something like this. And then when we unfold it again, it should be looking something like this. And so that's how we got our final answer choice, E. Problem number 3. Wind chill is a measure of how cold people feel when exposed to the wind outside. A good estimate for wind chill can be used by using this calculation. Wind chill equals air temperature minus 0.7 times the wind speed. And now they're going to give us some variables to put inside for those. So where temperature is measured in degrees Fahrenheit and wind speed is measured in miles per hour, suppose that the air temperature is 36 degrees Fahrenheit. So I'll be writing WC for wind chill. Wind chill, or I'll just write W for wind chill to not get confused. So W is equal to 36 degrees. So air temperature is 36. So I'm just replacing this into the actual formula. 36, and the wind speed is 18. So the wind speed is 18. Then we'll be getting 36 minus 0.7 times the wind speed. And which of these is closest to the approximate wind chill? Which of these is the closest to these answer choices? So we can do that wind chill is equal to 36 minus 0.7 times 18. And 0.7 times 18 is approximately equal to 12.6. So wind chill is equal to 36 minus 12.6. And 36 minus 12.6 is equal to, well, we can say approximately 23.4, right? 23.4. So which of these answer choices is closest to 23.4? Well, if we round this to the closest integer, then wind chill would be equal to approximately 23. And so 23 would be our final answer, and that's how we got an answer choice B. Problem number 4. The numbers from 1 to 49 are arranged in a spiral pattern on a square grid, beginning at the center. The first few numbers have been entered into the grid below. Consider that 4 numbers will appear in the shaded squares on the diagonal on the same diagonal as the number 7. How many of these 4 numbers are prime? So they showed us these for the shaded areas, the shaded squares, are the 4 numbers. And how many of these are prime? Well, prime simply means that it has 2 factors, only 2, 1 and itself. An example of a prime number could be 2. So the factors of 2 are just 1 and 2, since only 1 times 2 make up 2. An example of a non-prime number is, suppose it can be 6. 6 can be made up of 1 times 6, and 2, 3. 2 times 3. So 6 has 4 prime. So 6 has 4 factors, so 6 cannot be prime. So an example would be 2. So, and we can just continue the spiral, and we'll be getting 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 will be in the first shaded square. So I'll write 19 here. 20, 21, 22, 23. Sorry, I'll write 23. So 23 is there as well. So I'll write 23 here because it falls under shaded square again. This one would be 24, 25, 26, 27, 28, 29, 30, 31, 32. And if we keep going, then we're going to get 33, 34, 35, 36, 37, 38, and 39 will be following in the shaded area. So I'll write 39 here as well. And then if we continue, we'll be getting 40, 41, 42, Almost there. 43, 44, 45. So 45 will be going there. 46 and 47. 40, sorry, I'll write 47 here as well. 47, 48, and 49. And we completed the square, and just to double check, this is a 1, 2, 3, 4, 5, 6, 7, 7 by 7 squared. So that means that there should be 49 of these numbers, and there's 49 numbers here. So we're right on track. And we have 4 numbers right here. And which of these, how many of these numbers are prime numbers? So to know if these numbers are prime or not, what is 19 made out of? 19 is made out of 1 times 19. Is it made up of anything else? No. How about 23? 23 is made up of 1 times 23. So 23 is also a prime number. 39 is made up of 1 times 39. And it's also made up of 3 times 13. So 39 is not a prime number. So we need to cross off 39. How about 47? 47 is made up of 1 times 47. And so 3 out of the 4 numbers are prime numbers. And so that's how we got our answer choice D. Problem number 5. A lake contains 250 trout, along with a variety of other fish. So they told us that trout is a kind of fish. When a marine biologist catches and releases a sample of 180 fish from the lake, 30 of them are identified as trout. Assume that there is the same ratio of trout to the total number of fish in both of the sample and the lake. How many fish are in the lake? So there's 180 fish from the lake, and 30 of them are identified as trout. And so the ratio would be 6 in every 6 fish, there's at least 1 trout. And the lake contains 250 trout. So in this case, then we're going to get x2 250. So 1 times what equals 250? Well, 1 times 250 is equal to 250. And so we have to do 6 times 250 to get the value of x. And so when we do 6 times 250, well, we can just simply multiply this, and we're going to be getting 1,200 plus 300, and we'll be getting 1,500. And so that means that there are these many fish in the lake. This is 1,500. And so that's how we got our answer choice B. Problem number 6. The digits 2, 0, 2, 3 are placed in the expression below. 1 digit per box. What is the maximum possible value of this expression? So suppose that we can start off with, there's digits 2, 0, and 2, 3. Suppose that we start off with 2, 3, and there's also digits 3, 0. So we know that the 0 power, so anything times, so suppose that can be 1 to the power of 0 is going to be equal to 1. It can be 2 to the power of 0, and it's still going to be equal to 1. Well, there can be maybe 1,000 to the power of 0, and it's still going to be equal to 1. There can be any number. Suppose that can be 50,000 to the power of 0, and it still equals 1. This is called 0 power, and so x to the power of 0 is always going to be equal to 1. So 2 to the power of 3 here is going to be equal to 8. 8 times 1 is just going to be equal to 8. But is this the largest value? Well, let's put a question mark for this one. How about we can try 3 to the power of 2 times 2 to the power of 0. And we're going to be getting 9 times 1 is going to be equal to 9. So 9 is the largest value so far. How about we can try 3 to the power of 2 times 0 to the power of 2. Well, in this case, we'll be getting 9 times, well, 0 to the power of 2 here is going to be equal to 0 times 0, which is going to be equal to 0. The same thing applies for 0 to the power of 10. 0 to the power of 10 will be equal to 0 times 0 times 0 times 0 all the way up till 10, and that's still going to be equal to 0. So the value of this expression is going to be 9 times 0, which is going to be equal to 0. And so if we try trial and error, we're going to be getting the largest value of this is going to be equal to 9. And this is how we go to answer choice C. Problem number 7. A rectangle with sides parallel to the x-axis and y-axis has opposite vertices located at 15,3 and 16,5. A line is drawn through the points A, 0, 0 and B, 3, 1. Another line is drawn through the points C, 0, 10 and D, 2, 9. How many points in the rectangle lie on at least one of these two lines? So we have a coordinate point right here, these coordinate grid right here, and they also gave us some points for this. So here, they told us that 15,3 and 16,5. 15,3 is here, and 16,5 is right here. And once again, this is 0, 0, this is 3, 1. They told us it's right here. And C is 0, 10, and D is 2, 9. So this point right here, so we have these points right here. And so how many points of the rectangle lie on at least one of these two lines? So here, I have this line, and I'm going to keep extending it. Just keep going down, down, down. Sorry, this is going to just keep going down. I'm just going to make it go down. And will it intersect any of these points right here? No, it won't intersect any of these rectangles right here. How about this one? Well, here, if we keep going, it'll intersect this point right here. And just to double check, let me show you a different way to do this. So here, A goes 1 up and 3 to the right to reach B. The same thing, if we keep going like this, we're going to keep getting this point right here. And if we keep going, it'll just keep being the same. We keep going and we'll get this line right here. So the line will be just this one right here once again. And so it will intersect one of these points, just one point right here. And that's how we got to answer choice B. Does anyone have any questions on this problem? Okay. So problem number 8. Lola, Lolo, Tia, and Tio participated in a ping pong tournament. Each player competed against each of the other 3 players exactly twice. Shown below are the win and loss records for each players. The numbers 1 and 0 represent a win or a loss respectively. For example, Lola won 5 matches and lost the 4th match. What was Tio's win-loss record? So, for example, Lola won 5 matches and lost the 4th match. So Lola right here, she won 5 matches but lost the 4th match. Okay, that makes sense. They told us that right there. Here, Lolo won the 1st match, lost the 2nd, won the 3rd, lost the 4th, won the 5th, and lost the 6th. Tia lost the 1st, won the 2nd, lost the 3rd, won the 4th, lost the 5th, and lost the 6th. What was Tia? Well, here, let me tell you something. So, if someone wins a game, then someone else would have lost a game, unless it's a tie. But here, there's no ties so far. So, if someone lost a game, then someone else would have won a game. And if someone won again, then someone else would have lost again. And so it has to be equally balanced. And so here, in this case, so suppose that we don't know who played with who, but there always has to be 2 wins and 2 loses. So Lola won and Lola also won. That means that Tia lost and Tia also lost. So here, it'll be 0 here. In the second one, we know that there's 2 wins, meaning that there has to be 2 loses. So 1 represents a win and 0 represents a loss. They told us this right here. So Tio lost the 1st game, lost the 2nd game as well. For the third game here, Tio lost as well since there's already two wins. For the fourth game, Tio won since there's only one win right here. And the other person who won must be Tio. So Tio won the fourth game. For the fifth game, Tio lost. And for the sixth game, Tio won as well because once again, there's only one win right there. So this is how Tio's win-loss record should be, and which of these matches these answer choices? So A matches. How about B? B here, B does not match because it shows that Tio won the third game, but Tio actually lost the third game. This is not possible as well because it says that Tio won the second game, but Tio did not. And it says that Tio lost all of the other games, but no, this is not true. D does not match because it says that Tio won the second game, but Tio actually lost the second game, so this does not work. And here E says that Tio won the second and third game and lost every other match, but this is not true. And so the only answer choice that matches this win-loss record is A. Problem number 9. Malalika is skiing on a mountain. The graph below shows her elevation in meters above the base of the mountain as she skis along the trail. In total, how many seconds does she spend at an elevation of 4 and 7 meters? So here, this is right here, 7. I'll just write 7 here. Oh no, that's not 7. This is 7 right here, and this is 4. So how much time does she spend between 4 meters and 7 meters? So whether she goes like that, like in a curvy motion, whether she just goes in a straight line, she will spend the same amount according to this line here. So she starts at here, and this is at 2 seconds. This is time in seconds, so this is at 2 seconds here. And then she goes to 4 meters. And 4 meters here, she spends a total of 2 seconds. From 7 to 4. Continuing, from 4 to 6, this does not count because she's below 4 meters, so this does not count. So from here, again, she reaches this point, which is located at 6. And to go to 7, she goes to 10. So from 6 to 10, there's 4 seconds. And then she goes above 10, above 7, which does not count. And then she goes back to 7, and then she goes back down to 4. And so this is another 2 seconds. And we're just getting the seconds from this time right here. This is 2 seconds, 4 seconds, 6 seconds, and so on. And this is the elevation in meters here. And we need to know the time in seconds. Well, the time in seconds is going to be equal to 2 plus 4 plus 2. And if we add this all up, we're going to get 6 plus 2, which is equal to 8. And that's how we got our answer choice B. Problem number 10. Harold made a plum pie to take on a picnic. He was able to eat only 1/4 of the pie and left the rest for his friends. A moose came by and ate 1/3 of what Harold left behind. After that, a porcupine ate 1/3 of what the moose left behind. How much of the original pie still remained after the porcupine left? So this problem you have to go step by step and writing each of the parts where someone came and ate it and then left the rest for the others. So Harold made the pie and he only ate 1/4 of the pie, meaning that if suppose that 4/4 is a total and he only ate 1/4 of the pie, then what is remaining? 4/4 minus 1/4, which is equal to 3/4. So 3/4 is remaining. Then a moose came by and ate 3/4 and ate 1/3 of the 3/4. So 3/4 minus 1/3, which is equal to we can do the least common multiple, which is 12, least common denominator, which is 12. And then we're going to be getting 12, 9 by 12 minus 4 by 12. And then we're going to be getting 5 by 12. So 5 by 12 of the pi is still remaining. Then then a porcupine ate 1/3 of the 5/12s, meaning that you have to do 5 by, here. So, sorry, let me explain this once again. So a moose came by and ate 1/3 of what Harold left behind, meaning that you have to find 1/3 of the 3/4. So instead of subtracting, you have to actually solve 1/3 of the 3/4 and then subtract that from 3/4. So 1/3 of 3/4. The word of just means multiplication. So 1/3 times 3/4 is equal to 3 by 12. And so the moose came and ate 3 by 12 of 3 by 4. And so that means that there's still 3 by 4 is equal to 9 by 12. So 9 by 12 minus 3 by 12 to get what is still remaining. And this is going to be equal to 6 by 12. So now that means that 6 by 12 of the pi is still remaining. It just means that 1/2 of the pi is still remaining. Then a porcupine ate 1/3 of 6 by 12. So 1 by 3 of 6 by 12 is just 1 by 3 times 1 by 2, which is equal to 1 by 6. 6 by 12 is also represented as 1 by 2. And so we need to get 1 by 2 minus 1 by 6. And if we solve 1 by 2 minus 1 by 6, we're going to be getting 3 by 6. Remember how 1 by 2 is represented as 3 by 6? Just multiply the numerator and the denominator by 3. We're going to be getting 3 by 6 minus 1 by 6, which is equal to 2 by 6. And if we divide by 2 the numerator and the denominator, then we're going to be getting 1 by 3. And so 1 by 3 of the pi is still remaining after the porcupine left. And that's how we got our answer choice D. Does anyone have any questions? Sorry for the confusion. Okay. So if no one has any questions, then we'll continue on to problem number 11. So problem number 11. NASA's Perseverance rover was launched on July 30th, 2020. After traveling 292,526,830 miles, it landed on Mars in Jezero crater about 6.5 months later. Which of the following is closest to the rover's average interplanetary speed in miles per hour? So they're just asking what is the closest? What is the closest to the rover's average speed? So just the closest, and these asteroids are not really that close apart. So we can just round it, just estimate it. So this number right here, it's closest to 300 million. So I'll just write 300 million. It just differs by about 8 million, so it's very close. And we will have to divide this by 6.5 months. Instead of writing 6.5 times months, we could just do 6.5 times 30. But we would also have to do times 24, since they're asking what is the speed in miles per hour here. And miles per hour, we can just do 24, since there's 24 hours in a single day. And here, we can just start by canceling these out. So 30, 30 on the top. And then we're going to be getting 10 million 10 million over 6.5 times 24, and 6.5 times 24 is equal to 156, which is closest to 160, just as in 160. And then when we divide 10 million by 160, then we should be getting 62,500, which is which is about 60,000, right? And this is closest to answer choice C. And remember how we're just rounding it. It's just like the average. It's just like the closest. They said that right here. Which of this is closest? And this gives us answer choice C, 60,000. Problem number 12. The figure below shows a large white circle with a number of smaller white and shaded circles in its interior. What fraction of the interior of the large white circle is shaded? So for this question, there's going to be two solutions, which I'll be telling you. There's one, part A, which will be taking more time, but it's more accurate, and part two, which is just a shortcut, but I'm not sure if this shortcut is just for this problem, or it might be from any other answer for any other problems as well. And so I'll be telling you the more accurate answer solution first, which is part A. Solution A. So here, we know that the area of the circle, to find the area of the circle, the formula would be pi radius squared, pi r squared. So in this case, we could just substitute this formula into this whole entire circle right here. So what fraction of the interior, the inside part of the large white circle is shaded? This is a large white circle which they're talking about. So first of all, we need to find the total area of that. And the area of that, we know that the diameter would be equal to, well, 1, 2, 3, 4, 5, 6. And we know that half of the diameter is the radius. So half of the diameter is just 1, 2, 3. So the radius would be 3. Here. So if the radius is 3, then the area of the total large white circle would be equal to pi r squared, which is pi 3 squared, which is equal to pi times 9, which is just area is equal to 9 pi, which is, instead of writing pi times 9, I'll just write 9 pi. So here, 9 pi of the total large white circle. Well, to find the shaded area of the inner circle, we'll have to do that. We know that each of these circles right here, the small circle, this one, and this one, each of those, to find the area of that, we know that the total diameter is equal to 1, right? Because each of these squares is just 1 by 1. So this part right here, half of that would be 1 by 2, right? Because half of 1 is just 0.5, which is 1/2. So the area of these smaller circles would be equal to, pi r squared, which is just pi times 1 by 2 squared. And instead of writing pi times 1 by 4, I'll just write pi by 4. Okay? And we know that there's 3 circles like this. Not just one, there's 3 of these smaller circles. So I'll write 3 pi by 4. Instead of writing 3 times pi by 4, 3 pi by 4. So here we got 3 pi by 4. And now we need to find the shade of this circle minus these 2 smaller white circles. So the area of this small circle, large circle, the shaded circle, would be equal to pi r squared. And the radius is 2, just half of the diameter. So pi 2 squared, which will be equal to 4 pi. And the area of these 2 smaller white circles inside of the shaded circle would be equal to pi, I'll write this right here maybe, which will be equal to pi times radius squared, which is pi times 1, which is just equal to pi. But remember that there's two y circles. And so that would be 2 pi, right? Since there's two y circles inside here. And so to find the area of just the shaded part, we can do this whole circle right here minus these two white circles. And we're going to be getting 4 pi minus 2 pi, which will be equal to 2 pi, right? Because 4 minus 2 is equal to 2. And now here, now see this shaded part is here. And we know that the value of this shaded part here is equal to 2 pi. Then we know that the fraction of the interior circle over the whole circle, over the whole white circle, is going to be equal to 3 pi by 4 plus 2 pi over the total area of a large white circle, which is 9 pi. And so we're going to be getting, so 2 pi is just represented as 8 pi by 4, right? Because we can just multiply by 4, and we're going to be getting here. Since there's not much space here, I'll just write it here. And so we're going to be getting 3 pi by 4 plus 8 pi by 4 over 9 pi. And here, now, we'll be getting 11 pi by 4 times 11 pi by 4 times 1 by 9 pi. And so the pi and the pi will cancel out here. Instead of dividing by 9, I just move the 9 into 1 by 9 because we can keep, change, and flip. And here we'll be getting 11 by 4 times 9, which is going to be to 36. And so our final answer would be equal to 11 over 36b. Does anyone have any questions on this? Okay, so if no one has any questions, then I'll explain you part B, solution B, which is not very accurate. For this problem, it's a shortcut to do this problem, but just remember solution A because you can use it for other problems as well. But solution B here, so this is the one right here. So assume that this large white circle is equal to, suppose that each of these is equal to 1 unit. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the area of a large white circle is equal to 36. Okay, just assume. This is not correct because we don't know, because we're just not calculating anything, we're just counting. So this is not accurate, but it's just a solution, just a shortcut. And so now we know that this part right here, 1, 2, 3, 4, by 1, 2, 3, 4. So this part right here, this circle right here is by 4 by 4, which is equal to 16. But in 16, we have to subtract these white circles as well. 1, 2, 3, 4, 1, 2, 3, 4. So 16 minus 4 minus 4 is equal to 16 minus 8, which is equal to 8. But then 8 is just the solution right here, just the shaded area right here, and the shaded area right here. And we also have to add these small circles. And these cover approximately 1 square unit. So 1 plus 1. This is approximately 1, and this is also approximately 1. And so 8 plus 1 is equal to 8 plus 3, which is equal to 11. And we need to subtract, and we need to divide 11 by 36, right? 36 is the total area. And so our final answer would be equal to 11 over 36. Does everyone understand both of these solutions? Solution A and solution B? If you have any questions, please unmute or raise your hand. Okay, so problem number 13. Along the route of a bicycle race, 7 water stations are evenly spaced between the start and the finish lines, as shown in the figure below. There are also 2 repair stations evenly spaced between the start and finish lines. The third water station is located 2 miles after the first repair station. How long is the race in miles? So there's 7 water stations that are evenly spaced. Okay, so these are all evenly spaced between the start and finish. But they also said that there's also 2 repair stations evenly spaced between the start and finish line. So here, this can be the first water station, second water station, the third water station, fourth, fifth, sixth, and seventh. Just assume that these are evenly spaced, and this is just the finish line. So here, the finish one would be, if there's 7 water stations, that means that there should be 8 even parts, right? 1, 2, 3, 4, 5, 6, 7, 8. 8 even parts. So this is 8 distance. D represents distance over the total distance, which is 8. So 8 by 8 is just going to be equal to 1. So distance is equal to D. For the first one, it'll be equal to D by 8, right? Distance over 8. The second one will be equal to 2D by 8. The third one will be equal to 3D by 8. The fourth one, 4D by 8, and so on. And the seventh one should be equal to 7D by 8. Well, for the repair stations on the other hand, we're going to be doing the repair stations maybe placed somewhere, suppose it can be placed somewhere here and somewhere here. This is just approximate. So this one would be, the finish line should be 3D by 3, right? Since there's 3 parts, 3 even parts for 2 repair stations. And the third one is just the whole distance, which is just 1. The second repair station should be 2D by 3. And the first one should be D by 3. We can also represent this as 1D by 3, but it's just easier to write D by 3. They also told us that the third water station is located 2 miles after the first repair station. So here, the third water station, which is 3D by 8, 3D by 8 is equal to 2 miles after 2 plus the first repair station. The first repair station is D by 3. And here, we just made an equation. Well, now we need to solve this equation. And to solve this equation, we can try to move this 2 inside the fraction bar as well. But to do that, we'll have to do 3D by 8 equals, we know that 2 times 3 is equal to 6. So 6 plus D by 3. And now we can just solve this. So we're going to be getting cross multiplication to get rid of the fraction bar. To get rid of the fraction, we just make a simple equation. We're going to be getting 9D equals 48 plus 8D. Once again, we just cross multiplied here to get rid of the fraction bar. And this is our final equation. Well, to solve this, we can subtract 8D on both sides, and when we do that, we're going to get the total distance is equal to 48. And so that means that the total distance of the route of the bicycle race is equal to 48 miles. And that's how we got an answer choice D. Problem number 14. Nicholas is planning to send a package to his friend Anton, who is a stamp collector. To pay for the package, Nicholas would like to cover the cost to cover the package with a large number of stamps. Suppose that he has a collection of 5-cent, 10-cent, 25-cent, with exactly 20 of each type. What is the greatest number of stamps Nicholas can use to make exactly $7 in the postage? Note that the amount $7.10 corresponds to $7.10, meaning that this is just for like the people who don't know like what the sign means. And we know, and they also told us that each dollar is worth 100 cents. So, um, here they said that there's exactly 20 of each type, meaning that there's three types of stamps, and so the total stamps would be 20 times 3, which will be equal to 60. And so that means that there's a total of 60 stamps. Well, to find the value of all of these stamps, well, if we add all of these up, then we'll be getting the total values equal to $8. But we actually need $7.10. We don't need more than that, just $7.10. Because we don't want to pay more than that. So $7.10. But $7 and $8 minus $7.10. To find the difference, we would have to solve it, and that would be equal to 90 cents. 90 cents. So we need to make 90 cents using the least amount of different types of money. So that means that we don't want to waste all of our 5 cents on the 90 all of the 5-cent coins on the 90 cents. So we want to use as many 25s as we can, and then we go to the tens, and then we go to the fives. So in this case, to make 90, we can use 25 times 3, right? Which will be giving us 75. So 3 25s. And then we would also do 75 plus, and then we're going to be remaining with 15 cents. To make 15, we can do 5 and 10. Right? And we're going to be getting 2. So 3 plus 2 will be 5. So we'll be using 5 types of 5 coins to make 90 cents. And we will need to subtract this from the total. So 60 minus 5 will be equal to 55, meaning that we will use 55 coins to make $7.10. And we want to make 90 cents using the least amount of coins because we want to use as many coins as we can. Because asking what is the greatest number of stamps Nicholas can use to make exactly $7.10 in postage. If they said what is the least amount, then we would try to waste up and we would have to try to use up all of the 5 cents on the 90, and then we would go to the 10, and then we would go to the 25s. But now there's asking for the greatest number of stamps that they can use. So we would have to use the least number of coins to make 90 cents so that we can use the other coins to make $7.10. And that's how we got our answer choice E. Problem number 15. Vishwan walks half a mile to go to school each day. His route consists of 10 city blocks of equal length, and he takes 1 minute to walk each block. Today, after walking 5 blocks, Vishwan discovers that he has to make a detour, walking 3 blocks of equal length instead of 1 block to reach the next corner. From the time he starts his detour, at what speed in miles per hour must Vishwan walk in order to arrive at school at his usual time? So he walks half a mile to get to school each day, and he takes 1 minute to walk each city block, and he walks 10 city blocks, meaning that to travel half a mile, he would take 10 minutes. To travel 1 mile, he would take twice the amount of minutes. So 1 mile would take 20 minutes. In 60 minutes, he would travel 3. And we did 60 because there's 60 minutes per hour. So his speed would be 3 miles per hour by walk. So now we know that his speed is 3 miles per hour. And now he walked an extra 3 blocks. And he walked an extra 3 blocks. So he would have to do, instead of 5 blocks as normal, so 5 blocks normal, he would actually do 1, 2, 3, 4, 5, 6, 7 blocks instead of 5 blocks. And so we have to multiply 7 by 5 times 3 because we know that his rate, we usually do 5 by 5 times 3. But now, instead of 5, we have to add an extra 2 blocks. So that means that 7 by 5 times 3 would be equal to 21 by 5, which will be equal to 4.2. And that's how we got our answer choice B. Does anyone have any questions on this problem? Okay, if no one has any questions, then we'll take a 2-minute break. Okay, we can get started with problem number 16 now. And we just finished problem number 15 and everything before that. So we can get started with problem number 16. The letters P, Q, and R are entered in a 20 by 20 table according to the pattern shown below. How many P's, Q's, and R's will appear in the completed table? So instead of making all of the 20 by 20 table, instead of like continuing this pattern, since we don't know which way it'll go across, we can just look at this 5 by 5 grid right here, and we can just look at the answer choices and we can answer this question. So we can start by counting the number of letters in this 5 by 5 grid. So how many Q's will there be? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 Q's. Let me use a different color. How many R's will there be? 1, 2, 3, 4, 5, 6, 7, 8. 8 R's. And another color. How many P's will be there? 1, 2, 3, 4, 5, 6, 7, 8. 8 P's. So the meaning of this is that there must be one more Q than R's and P's. So in this answer choices, that means that there must be one more Q than R's and P's. So Here, there's there's two more Q's and two more R's than P's. So this is not the answer. In B, there's one more R than P's and Q's, but this is not the answer choice either. This cannot be the answer either. Here in C, there's one more Q than P's and R's, which can be the answer. I'll just put a check mark here. For D, there's two less Q's than P's and R's, which is not the answer. And for E, there's one more P than Q's and R's, which cannot be the answer either. And so by using elimination, we found out that the answer choice must be C. Problem number 17. A regular octahedron has 8 equilateral faces with 4 faces meeting at each vertex. Juno made the regular octahedron shown at right by folding the pieces of paper shown on the left. Which number will end up to the right of Q? So this is Q right here, and one of the edges which meet with Q is 6. So we know that 6 meets with Q, and by using folding, we must know that 6 must go here. Because 6 is on the left of Q, so it must go here. So one of the edges, which all of the edges that meet with 6 are 7, 5, and Q. Q is right here. That means that 7 must go in the back, right there, and 5 must go right here, since the edges that meet with 6 are right there. So 5 must go down there. This should be 7. So now here, we know that, see this vertex right here, this point right here, that point is equal to this point right here. That means that if it's that point, that means that this side must be 4, 3, and 2. Well, it doesn't really matter which order it is. And 1 does not meet in this vertex. That means that 1 must be on the right of Q, because we know that 7 is already there, 6 is already there, Q is already there, 5 is here, 4 is here, 3 is here, and 2 is here. That means that 1 must go there. There's no other option for 1 to go. And so our final answer is 1. Here, 1. And that's how we got our answer choice A. Problem number 18. Greta Grasshopper sits on a long line of lily pads in a pond. From any lily pad, Greta can jump 5 pads to the right or 3 pads to the left. What is the fewer number of jumps Greta must make to reach the lily pad located 2023 pads to the right of her starting point? So, Greta Grasshopper is 2023. She wants to go there. That is her final destination. But here, this number, or anything, if we add something to this number, that must be the closest number that is divisible by 3 and divisible by 5 as well. And so we can keep continuing to add 3 to this, because we can just keep going and add 3 to this. And we're going to be getting 2, 0, 2, 6, 2, 0, 2, 9, 2, 0, sorry, 2, 0, 3, 2, and 2, 0, 3, 5. And when we reach 2, 0, 3, 5, we realize that it's divisible. We realize that this number is divisible by 5 here, because this number ends with a 5. And here, if we divide this number by 5, then we're going to be getting 407. So if we make 407 jumps from 0, we should be getting this number. But here, we would also have to go back 3 steps. So back 3, and we have to do that 4 times to get 2023. And so we have to jump 4 steps back, and so you have to add 4 steps to this number as well, which will be getting 4,411. And so that's how we got our final answer D. Problem number 19. An equilateral triangle is placed in a larger equilateral triangle so that the region between them can be divided into three congruent trapezoids. An example would be this one right here. So this congruent trapezoid. And the side length of each of these inner triangles is 2/3 the side length of the larger triangle. What is the ratio of the area of one trapezoid to the area of the inner triangle? So to find the ratio of this, or to find the length of one trapezoid, so T for trapezoid, the trapezoid would be equal to the area of the outer triangle minus the area of the inner triangle divided by 3, since there's 3 trapezoids right here. But then to find the area of one equilateral triangle, whether the equilateral triangle is supposed this big or maybe just this tiny, they have the same formula. And the area of that would be equal to, the area of an equilateral triangle would be equal to, this is just the formula, the square root of 3 by 4 side length square, a square. So to find the area of the outer triangle, we know that inner triangle is 2 by 3x, right? This is 2 by 3x, and the outer triangle is just x. And so the area of the outer triangle would be equal to the square root of 3 by 4 x squared minus the inner triangle, which is the square root of 3 by 4. This is 3 by 4, which is 3 by 4, times 2 by 3x by 3, right? We have to divide the whole thing by 3. And when we solve this, we're going to be getting the square root of 3 by 4 x squared minus the square root of 3 by 4 times 4 by 9 times x squared. I forgot to write the square here, but we would also have to do a square here because of this formula. So this 4 and this 4 would be canceling out, and we'll be getting the square root of 3 by 4 x squared minus the square root of 3 by 9, because once again, this 4 and this 4 will be canceled out because of multiplication and division. Therefore, x squared divided by 3. And we would have to divide this whole thing by the inner triangle because we need to find the ratio of one trapezoid, the area of one trapezoid, to the area of the inner triangle. So the ratio is just, another way to write ratio is division. And so we can divide this whole thing by the area of the inner triangle, which is the square root of 3 by 9 x squared, right? So here we got this because this is the area of the inner triangle. Inner triangle just represents I here. And this is the area of the inner triangle. So we can cross out the x squared right here. And we'll be getting here. I'll write this. Sorry, this is 3. I'll write this right here since there's not much space to write this. We'll be getting 1 by 3. Instead of writing divisible by 3, we can just write 1 by 3 times the square root of 3 by 4 minus the square root of 3 by 9 times 9 by the square root of 3. Instead of writing divisible by 9 again, or 3 by 9, we can just cancel this out. We can just write times 9 by the square root of 3. Does everyone understand how I got from here to here? Please let me know if you don't understand. So from here, we can try to move the square root. Instead of having square root of 3 in the numerator inside the parentheses, we can try to get them outside. And so when we try to do that, we're going to be getting the square root of 3 by 3 times 1 by 4 because we tried to, and we got 1 by 4 because we removed the square root of 3 on the top and we moved outside the parentheses. 1 by 4 minus 1 by 9 times 9 by 3. 9 by the square root of 3, sorry. The square root of 3, this square root of 3 cancels out. This 3 and this 9 will be canceling out into 3 right here. And so now we're going to be left with 1 by 4 minus 1 by 9 times 3, which is equal to 9 minus 4 by 4 times 9, because here we got that times 3. This 3 will be here, and this will be 1. And we're going to be getting 9 minus 4 by 4 times 3, which is 5 by 12. 5 by 12. And that's how we got our final ratio answer. This is division, but once again, we can transform this fraction into a ratio, which should be equal to 5 to 12. By this, I mean 5 colon 12. And that's how we got our final answer, C. Does anyone have any questions on this problem? Okay. Problem number 20. Two integers are inserted into the list 3, 3, 8, 11, 28 to double its range. The mode and median remain unchanged. What is the maximum possible sum of these two additional numbers? So we added two integers. And this means that we double the range. Well, the range just means the largest value minus the smallest value. So the range should be equal to, the range is equal to 25. Because it's 28 minus 3, which is equal to 25. And so, now we're going to be doing, to double the range, to find the double range, we're going to be doing 25 times 2, which should be equal to 50. And so that means that the range should be equal to 50, which means that 50 minus 3 should be equal to 50, should be equal to 47. But we need that 47 does not equal 50. And so for the range to be equal to 50, we'll have to add 3 to 50 to get 53. And so the number that we add is 53, because 53 minus 3, which is the smallest value, is equal to 3, is equal to 50. And so 53 is one of the integers we add. But we need another integer. And that number must be less, and that number must be less than 8, because we don't want the median to change. We want the median to stay the same. And we don't want it to be 8 either, because we don't want the mode to change. We just want the mode and the median to be the same. And so the smallest value that is less than 8, which is an integer, is 7. And so another number that we add is 7. So 53 plus 7 is equal to 60. And so that is the sum of the two additional numbers. And that's how we got our answer choice D. Problem number 21. Alina writes the numbers 1, 2, 3, and 1, 2, and so on till 9 on separate cards. One number per card. She wishes to divide the cards into 3 groups of 3 cards so that the sum of the numbers in each group will stay the same. And how many ways can this be done? So we can use trial and error to find out how to place 3 groups of 3 cards in each group so that the sum can be the same. We know that 1, 2, 3 should be separate, 4, 5, 6 should be separate, and 7, 8, 9 should be separate. Otherwise, the sum will be too much or too less. So by using trial and error, we know that 8, 3, and 4 should be together. 1, 5, 7 should be together, and 6, 9, 2 can be together. 6, 9, 2 should be together. And now we can see that 1, 2, 3 are separate, 4, 5, 6 are separate, and 7, 8, 9 are separate once again. Another way to do this is doing 8, 8, 1, 6, 3, 5, 7, and 4, 9, 2. So these are the only two ways to do this. And once again, if you look at both of these possibilities, 1, 2, 3 are separate. 1 is here, 2 is here, and 3 is here. 4, 5, 6 are separate, and 7, 8, 9 are. Yeah, someone has a question? You can unmute.
The first one can't be true because the sum isn't the same. The sums are 15, 13, and 17.
Oh, for the first one?
Yeah, that's right.
Oh, okay. Matt, then you can use some other ways by doing trial and error. And you can just try to place it. So you can do 1, 2, and 3, which should be separate again. And then you can try doing, maybe you can do 9, 8, and 7. And then you can try to do some other ways to do this. Maybe you can do 4, 5, 6. You can do many different ways to try to do this. And you can just try to do trial and error. And I'm pretty sure that this can only be done in 2 ways, since we know that 1, 2, 3 has to be separate, 4, 5, 6 has to be separate, and you can just do trial and error. I'm not exactly sure about this one, but I'm pretty sure that there should be only 2 ways to do this. I can tell you the proper solution to this maybe tomorrow. So we can do problem number 22. In a sequence of positive integers, each term after the second is the product of previous 2 terms. The sixth term in the sequence is 4,000. 1 is the first term. So there is a sequence of positive integers, and there must be six terms. So here we have, suppose that the first term can be a. We don't know what the first term is, but suppose that it's a. The second term can be b. The third term must be the multiplication of a and b, which is the first and second term, which is just a and b. The fourth term is a and b squared. You have to do b squared because a times b times b, which is ab squared. And the fifth one should be a squared and b3, b to the power 3. And the sixth one should be a to the power of 3 and b to the power of 5. And this is the sixth term. So the final answer should be equal to 4,000. But now we need a prime factorization of 4,000 to get the value of this. So 4,000 is equal to 4 times 1,000. And we can just simplify this, and we're going to be getting 2. 4 is represented as 2 times 2. And 1,000 represented as 10 times 10 times 10. And now we can prime factorize this, and we should be getting 2 times 2 times 2 times 5, because 2 times 5 is equal to 10 times 2 times 5 for another 10 And finally, 2 times 5 for the last 10. And we should be getting something like this. And instead of writing this, we could just use the power again, and we should be getting 2 to the power of 5 times 5 to the power of 3, which is the same thing as 5 to the power of 3 times 2 to the power of 5. And we can replace this right here. And we know that the first one should be equal to A, which is 5, and the second one should be equal to B, which is 2. And so they're asking, what is the first term? The first term should be equal to A, and A in this case is equal to 5. And so that's how we got our final answer, D. Problem number 23. Each square in a 3 by 3 grid is randomly filled with one of the 4 gray and white tiles shown below on the right. What is the probability that the tiling will contain a large gray diamond in one of these smaller 2 by 2 grids? Below is an example of such a tiling. So there's one way to do this. So one diamond right here, or I'll write the diamond, or I'll write the possibilities here. So 1, 2, 3, and 4. So there's 4 ways to do this. And here there's 4 different possibilities. So 1 by 4 for the first square times 1 by 4 for the next one times 1 by 4 for the third one and times 1 by 4 for another one. And we will have to do this times 4 since there's 4 gray diamonds possible. I just showed this right here. And there's 4 ways to possible, and then we can just do 4 by 1. So this 4 by 1 and this 4 by 1 will cancel out with each other. We're going to be left with 1 by 4 to the power of 3. And when we do this, we're going to be getting 1 by 16 times 4, which is 64. And this is going to be our final answer choice C. Problem number 24. Isosceles triangle ABC has equal side lengths AB and BC in the figures below. Segments are drawn parallel to AC so that the shaded portion of ABC have the same area. The height of 2 unshaded portions are 11 and 5 units respectively. What is the height h of triangle ABC? So this is the height of one, and this is the height of another one. And this area right here and this area right here must be equal. They said that they said that they have the same area, So I'm just gonna label this point right here something random, like maybe D, and this one maybe E. This one can be maybe F, and this one can be G. Here. So we know that this line right here must be the height minus 11, and this one right here must be the height minus 5. And so now we know that the ratio of this should be D E D over the total area, which is A B C equals 11 by H. Okay, and to find out just the length of this part, just the area of this part, and we have to do this square because to find the area we have to square this. And to find the area of this one right here, we have to do 1 minus that area. 1 minus the area of this part right here, DBE. So 1 minus 11 by h squared, in parentheses here. Now to find the length of this part right here, we have to do, we already know that. We already know that to find the length of this, we would have to do h h minus 5 squared. Since here, we can just do this. I'll just write this right here, for this part right here. So 1 minus 11 by 8 squared is equal to h minus 5, h minus 5 squared. And now we can just solve this. And this right here is a minus b whole square, which means that, here, I'll write this right here, and we'll be getting h squared minus 121, which is 11 squared, is equal to a minus b whole square formula, which is a squared minus 2ab plus b squared. So it will be h squared minus 2 times h times 5, which is 10h, because 5 times 2 is equal to 10, and we just have to do h right here, plus, or we can do minus 25, because there's a minus sign right here. So when we solve this h squared and this h squared will cancel out, and we'll be left with minus 121 is equal to minus 10h minus 25. And we'll be getting minus 146 is equal to negative 10h, equals negative 10h. And we'll be getting 146 equals 10h. H is equal to 14.6. 14.6 is equal to h. So that means that the total height is equal to 14.6, and that's how we got our answer choice A. Problem number 25. 15 integers, A1, A2, A3, and so on till A15 are arranged in order on a number line. The integers are equally spaced and have a property that A1 is less than or equal to A1 is less than or equal to 10. Or sorry, A1 is greater than or equal to 1 and less than or equal to 10. A2 is greater than or equal to 13, but less than or equal to 20. And A15 is greater than or equal to 241, but is less than or equal to 250. What is the sum of the digits of A14? So they're asking us to find what A14 is and add the digits all up. So to find what A14 is, we know that here A15 is equal to A1 plus some distance. We don't know what that distance is, but we'll have to add 14 distances. Since there's going to be 14 integers between A1 and 15, we'll have to add 14 distances. And then A14 should be equal to A1 plus 13D, because there's going to be 13 digits, something like that. A2, suppose we'll just jump to A2. A2 should be equal to A1 plus just one distance. And we can plug in this formula for everything that we need to solve. So we need to find out what D is, and we need to find out A1 is. And we can find out what any number is. So we know that 241 must be less than, or sorry, A1 plus 14D, and we got this because A15 is equal to A1 plus 14D. So A1 plus 14D must be greater than or equal to 241, but less than or equal to 250. And now we can substitute the value of A1 for this. So we know that A1 must be between 1 and 10. So we can subtract, to find the least value, we can subtract 241 minus the greatest value, and we can do 250 minus the least value of A1. So 241 minus 10 is equal to 231. And 250 minus 1 is equal to 249. So 14D must be between 231 and 249. So what's D? D must be anything times 14, which is between 231 and 249. And D must be equal to 17. Since 14 times 17 is equal to 238. Okay? So D must be equal to 17. And now we know the value of D. If we know the value of D, then we need to find out what A1 is. And we can substitute this for any value. And we'll just do A2 because it's pretty close to A1. So A2 must be between 13 and 20. And A2 is equal to A1 plus D. So if D is equal to 17, so A2 equals A1 plus 17, then we know that A1 must be, suppose that A2 is the greatest value possible. A1 must be equal to 3, assuming that A2 is equal to 20, right? Because it's the greatest value possible. So A1 is equal to 3 and D is equal to 17, then what is A14? They're asking what is the sum of the digits of A14? Well, first, what is A14? A14 is A1, which is 3, plus 13D. So 13 times 17. So times 17. So A14 is equal to 3 plus 13 times 17, which is 221. So A14 is equal to 224. A14 is equal to 224. But that's not an answer because they're asking what is the sum of the digits of A14? So the digits are 2, 2, and 4. So what is the sum of these digits? The sum of these digits is 2 plus 2 plus 4. And so 2 plus 2 plus 4 is equal to 4 plus 4, which is equal to 8. That means the sum of these digits must be equal to 8. And that's how we got our final answer, A. Does anyone have any questions on this problem? Or anything about what we talked about so far?